Okay, so as we look at the ones you wanted, 17, 18, 22, and 29, basically you are thinking about just putting a really big number, infinity, in for the x's, is what you're doing. Anytime you're seeing this, you're trying to see, okay, is it playing out to be 0, or maybe the the limit doesn't exist, or is it going to be infinity, or is it going to be work out to be a whole number because of the ratio? So as I look at 17, really in the grand scheme of things, I'm looking at the degrees, and so what draws my attention really is this part right here, the x squareds. Those two things are going to grow a lot faster than the 2x will. So really the 2x, no matter what we put in there for an x value, it's not going to make a big difference of what's there, because the x squared is going to overshadow it. You think about it. If I put x is equal to 10, I get 20 minus 100 pi over 100. If I put in x is equal to 100, I'm getting 200 minus 10,000 pi over 10,000. So really, the 2x isn't going to make an impact on what the overall limit as we go out to infinity with it. But what we can tell is, by the two examples that I've done so far, is that we can ignore the first part, and we're really basically going to have negative pi comes out of both of those, is what ends up happening. So as we go to infinity, that inside whole ratio, that rational function on the inside, really just works out to be negative pi. And so with that in mind, now we can say, okay, if that's really going to work out to be negative pi, then what is the cosine of negative pi? Well, that would be, that would be negative 1. On the next one, we can, and I think this is probably the easiest way, is when I'm taking the limit of this next part, I can take the limit of both pieces separately, is what I'm allowed to do. All right, so now we learned in today's lesson that the limit as x approaches infinity of sine x over x, that is just 0. And then minus the limit as x goes to infinity of the constant is just the constant. And so I'm just left with negative 4 for my final answer there. As I look at the next one, 22, e to the 7 is just a number. It's a big number. It's just a number, so it's not going to keep growing. It is a if you think about it, I'm going to round down to make it easy on the math. We know e is 2.718. Well, let's just say we have 2 to the 7th power. Well, that's going to work out to be 128. So the top is a fixed number. The bottom, that's my issue, 9 to infinity. Well, that's going to be some really big number whenever we pick out x to be. So we got about 128, something like that, divided by a really big number. Well, that's going to work out to be just 0, is what it's going to end up being in the long run. And number 29, that's a little bit challenging. There's a lot of stuff going on there. Again, to me, looking at the degrees, and I'm only going to focus in on those parts right there, because the 5 is not going to make a difference when I take the limit of it, when I take the limit of this whole thing. Because again, it's one whole rational function there. It's not two separate fractions like 25. And really the square root of 2 over 2 times x, that's not going to have a big impact on it. So really I'm just focusing in on the two pieces that I've circled. I have pi x squared over negative 2x squared. Well, if I put in a really big number, the x squares, no matter what, just cancel. So I really just have negative pi over 2. And then now I could take the cosine of negative pi over 2, and that would be, should be 0, is what that would be. Okay, so again, you know, as you're going through, it's in some cases where we're splitting it up. This case, we don't split it up in a sense of two separate fractions or two separate pieces. Here, I got to think about that one whole rational function part as a whole. But we can see that the 5 and the square root of 2 over 2x really doesn't impact it. And again, I'll bring back the example of number 17, the way I worked it out there. If I chose a number to put in there for x and just kept getting the number to be bigger, I'd realize that those things wouldn't make a difference. They'd be overshadowed by the other things.